Imagine this. Emily is walking down the sidewalk, distracted. As she is about to cross the street, a car appears at full speed. She has two options. Either she freezes and the car hits her, or she reacts just in time and manages to dodge it.
But what if both things happen? What if instead of one or the other, both occur? What if in one place Emily dies and in the other Emily survives?
This idea, as crazy as it is unsettling, originated from one of the most famous experiments in history, Schrodinger's cat.
Year 1935. Austrian physicist Erwin Schrödinger proposed an absurd situation, but one based on real laws of quantum physics.
A cat locked in a box. Inside this radioactive atom with a 50% chance of decaying in 1 hour. If it does, a radiation detector catches it, activates a hammer that breaks a vial of poison, and the cat dies. If it doesn't decay, nothing happens.
This relates to a real phenomenon, radioactive decay. Some atoms are unstable, which makes them capable of transforming into others, releasing energy as radiation. What's unpredictable is when this decay will occur. We can know there's a 50% chance that it'll happen within a certain time, but not exactly when.
While the box remained closed, we don't know what happened. And since in the quantum world systems can be in a superposition of states, that is, coexisting in more than one possibility at once, then, until someone's opened the box, the cat is both alive and dead. Both states exist in superposition. It is only upon observing the system that what is known as the collapse of the function occurs, the reality becomes defined.
But if that happens with an atom, why not with you?
And here comes one of the most fascinating and disturbing ideas in theoretical physics, the many worlds interpretation.
Formulated in 1957 by physicist Hugh Shriver III, this theory proposes something radical.
That when a system is in superposition, it's not that one possibility is chosen and the others vanish.
Instead, all of them become real, in parallel universes.
One where the atom decays and the cat dies.
Another where it doesn't and the cat lives.
One where Emily gets hit by the car.
And another where Emily dodges it.
In his experiment, Schrödinger wasn't trying to affirm that cat was in two real states at once. On the contrary, his paradox was a critic of the dominant interpretation at the time, the Copenhagen interpretation, which claimed that quantum systems remain in superposition until observed. But how can we talk about superposition when the consequences are as macroscopic as the life of a cat?
Years later, Ever proposed that the superposition doesn't disappear upon observation, but splits into alternate worlds. In each one, a different possibility manifests. And that changes everything.
Because if that's true, then an even more extreme idea arises: quantum immortality.
This concept was popularized by physicist Max Tegmark in the 90s, based on a thought experiment. A person plays Russian roulette with a mechanism dependent on the state of a quantum particle.
Each time they pull the trigger, there's a possibility of dying, and another of surviving. But if many worlds exist, then there's a universe where they always survive.
And if consciousness can only continue in the ones where the body doesn't die, that person never experienced that.
From their point of view, they survive again and again, no matter how low the odds.
An endless sequence of lives. A timeline where you always get away. A form of immortality.
But there's something we're missing.
Can we bring these quantum ideas into the everyday world?
The most honest answer is no.
For now. Quantum physics work at subatomic scales. Photons, electrons, isolated atoms. Not with cats, and much less with humans, who are open, gigantic systems interacting with millions of particles all the time.
That constant entanglement with the environment destroys any fragile quantum state. It collapses the superposition. It forces reality to choose only one option.
The so-called quantum decoherence is the phenomenon that makes the multiverse, if it exists, invisible to us. Because as soon as a particle interacts with its environment, quantum ambiguity is lost. Everything becomes classical, predictable, defined, and the cat is, inevitably, either alive or dead, not both.
Even if there were millions of universes where we survive,
what will happen with the body? Quantum immortality doesn't stop aging, nor can it stop cancer or diseases or mental decline.
At some point, even in those infinite universes, your body will no longer be able to survive. And then consciousness will have nowhere to migrate.
And one more thing, is eternal life even desirable?
What if you survive everything but live trapped in a disabled body?
Or in an improbable universe where everything feels strange, unbearable?
Maybe right now you're breathing in the only universe where you are alive,
Or maybe you're a consciousness traveling from universe to universe.
clinging to every possible version of life just to never face the final moment. The only certain thing is that we still don't know what happens when that moment arrives, and maybe we never will. But if all of this is true,
Then maybe dying isn't an option.